Formally or in a very naive sense, is basically collection of a lot of basic data types that contains data. One structure contain a lot of data, and we can define sometimes several methods and several specialized kind of functions are customized and defined just because of that data structure to perform efficiently. Different kind of, for different kind of tasks, we may have to define or we may have to choose different kind of data structures. The basic data structures that are available in Python is a list, tuple, set, and dictionary. These are the basic data structures that are available. We can create our own data structures if we want to, but most of the problems, almost all of the problems, mostly they are solved by these four basic data structures. Although a lot of these are not that efficient, there are efficient ways for customized kind of problems. We will see that efficiency when we will deal with the package NumPy that is faster than all of these. But we will see what kind of constraints are there to make it faster. Anyways, data set in a very loose term is collection. It is collection of a lot of values, a lot of data inside. And all these data structures, list, tuple, set, and dictionary, they are collection of data of heterogeneous types, which means one value can be integer, another element, let me call an element, another element or item. Another item or element can be of string type, another element can be of, let's say, floating point number, another element is a whole list itself, another element is a tuple, and so on. So different elements can be of different types. And that makes this heterogeneity, that makes these four data structures much more applicable and much more abstract, and they can be applied to almost all the problems. So let's see one by one and let's compare them together, because the best way to understand four of these is just to compare them, which can do what as compared to the rest. So let's compare them and learn how can we use those in detail. So list, first is list. List is ordered. Ordered here means it is indexable, which means there is the element number one is at position one element. There is an ordering of elements, first element, second, third, 25th element. There is an ordering of element with respect to their position. So that's what we mean by ordered. Changeable, or sometimes called more reasonable term or more usable term, is mutable. Mutable means once the list is created, as contrast to string, once the list is created, you can change its elements. For example, you can change the third element with another element, and that's perfectly fine. You can change it. That's what we mean by changeable, or more popularly called as mutable. Duplicates means the list can contain more than one element more than, at the position number 3 you can have the same item, and position number 5 you can have the same item, so the duplicates are allowed. Tuple, however, although ordered, there is an ordering of elements, there are indices of different elements. This is immutable. Once tuple is created, like strings, once the tuple is created, you cannot change different elements in the tuple. You have to create a new tuple if you want to, but you cannot change the items in the tuple, and the duplicates are allowed again. Set, on the other hand, is unordered, which means there is no indexing, there is no positioning, there is no first element, there is no third element, there is no fifth element. That's a collection without actually indexing. Because you cannot access a particular element with index, you cannot change it, but what you can do it, you can insert more elements and you can remove existing elements if you want to. Again, the set, like in mathematics, sets does not contain any duplicates, so one item appears just once. We will see the examples. Dictionary, a very, very, very powerful data structure. Again, dictionary is just like a set. It is a set, it is unordered. Again, changeable. You can change them. You can change the items. And the dictionary, and it does not have duplicates because it's basically a set. It is just like a set. The power of dictionary is each item consists of a pair, and one value in the pair is called key and another is called the value. For example, val is key for 12, name is key for ban, and so on. So we have seen this dictionary before in loops and stuff in just a very loose way, but that's really a very, very powerful data structure. And later on we will see in pandas, basically all the data is basically managed just like a dictionary. If you have a good knowledge of dictionary, you'll be having a very good grip very quickly on a big data science library or big data science package, which is called pandas, because each and everything in pandas is handled just like we are handling a dictionary. So it's a really powerful data structure to know about. So so list is mutable, dictionary is mutable, set is mutable in a sense that you can insert and remove elements. Tuple is not mutable, and that's the comparison theoretically what is there. All these types, each and every of them is a collection of different values, and the values can have different types. That's the abstract power of all these data structures. So in the next video we will actually try to get a good grip on list, tuple, set, and dictionary, and we will actually define them, code them, access different methods of those, and we will be trying to become comfortable with these data structures by coding them in Python. So hope to see you in the next video. Okay, continuing previous video, we were talking about data structures in the last video. So let's go to the Jupyter Notebook and see how a list can be defined or declared, how a tuple can be defined or declared, set, and dictionary. Let's see how can we make these data structures in Python. So then one by one we will compare how can we access elements of the list, how can we insert more elements in list, tuple, set, and dictionary, and see the comparisons of all these one by one, operation by operation. So let's see. So let's go to Jupyter Notebook, our friend. This file is getting lengthy. Let's make multiple files. Let's say this is part 1. Just save it, and let's make another file. For example, let's just close this file, or maybe stay it opened. Let's close this file and make another file. Python 3. Yeah, so let's name that file as this part 2. Let's start a new file. That file was, I mean, that was okay to stay with that file as well, but just let's make another file. Okay, so let's just have a markdown cell, and let's have a heading, data structures. Remember the markdown cells? I just introduced them, introduced those just in the very beginning, and then we just forget them because writing these description again and again will make the video lengthier, and the purpose is not to actually format the notebook. The purpose is just to show you the power of Python. So I just omitted writing these descriptions more and more, but just write a few descriptions in the start, and then we will forget again. Oh, that's amazing. Let's define a list. So list, any variable name, that's a variable name. List is let's say this. You define list by square brackets, and different elements, they are separated by comma. Let's say 1, 3, 4.9, name, anything, I mean, or 5, or maybe 3 again. So that's a list. Okay. Tuple, on the other hand, is defined using parentheses. So let's say 1, 3, 4.9, let's say name, and let's say 3 again. That's okay. That's a tuple. A tuple is defined so when you write parentheses, that means by default that's a tuple. The variable name has, I mean, if you have written T, that has nothing to do that. It's a tuple. That's because the Python is dynamically typed. When you will write the parentheses, that means the tuple is being defined. Let's define a set. Let's call the variable as s. The set is defined with these curly brackets. So let's say 1, 3, 4.9. I want to tell you that all these things they can contain, each element can have a different type. But then even if we include this 3 again, because the set cannot contain the duplicates, later on we will see only one copy of 3 will be there in the set, the other will, even if we want to include, it will not be included. Okay, then let's say a dictionary. Dictionary is again defined like a set, but each element is a pair separated by a colon. Let's say the key value is 23, that's a key value. That's a key, and the value here is a string. Let's say 2, 3, that's let's say the value. Now comma, now one element is there. This one element that consists of key and value pair. Another element may have a key with string. So the keys can be of different types, the values can be of different types. I mean, so abstract. So the key is let's say B, and the value for this is let's say 43. Then maybe we can have another key value pair with key as let's say C, and the value is let's say CCD, let's say charge coupled device. Okay, anyways, so now you know how to define the list, how to define a tuple, how to define a set, and how to define a dictionary. The difference is the main difference here is in dictionary, because one element consists of 2 values rather than 1. Okay, let's print that and see the types. Let's print all the types. Print type of, so let's print them. The type of L is, so the type of L is, just print it, that's L. Let's print that. Let's see the other types. Let's print the rest as well. So just copy them and paste. The type of list L is that, the type of tuple is T, and let's say we have T, then we have S, and then we can just replace this with S, and then we have let's say D, dictionary, and that's D. Okay, so let's print. So the type of L is list, the type of T is tuple, the type of S is set, the type of D is dictionary. Oh, great. So that's how you can define these lists. You can define list, you can define tuple, you can define set, and you can define dictionary. No problem. Next, let's see how to access different elements from these data structures. What are the way, for example, to access an element from a list? Let's say the element number, element that indexed with 1. Remember, the element that indexed with 1 is element number 2, because the indexing starts from 0. So you can access that using the square brackets. If you want to access from tuple, again from the square brackets, exactly like the list. In set, for example, you cannot index it because the set has no ordering. First, second, third element is no longer there. But you can check whether a particular element is there in the set or not using in keyword. In dictionary, for example, if you want to check whether a particular element, if you want to access value for a particular key, you just write the dictionary variable name and then write the key, and it will return the value. Okay, so let's practice this in Jupyter. Let's just practice this in Jupyter. So let's say list value at index 1. So let's print this list at index 1. The value should be printed as 3. Print tuple at index 1. Again, the way of accessing is the same. Print whether 3 in S or not. The return value will be true or false. So print will be true or false, and then print D, and just access the value with the key 23. So let's see what happens. So L at index 1 is 3, T at index 1 is 3, S 3 is in S, yes. And what is the value with the key 23? The value is 2, 3. Let me just describe more about this D. What is the value at index B, for example? Now we have to give the index B in the string format. That's 43. Yeah. So that's how we can access that. Let's print S also. Let's see S, because when we have defined S, we have defined this duplicate 3. But if you see the elements of S, there are no duplicates, and it does not maintain even any ordering. I mean, we have defined S in a different way. It is maintaining everything maybe in a different way. 1, 3, yeah. Oh, the ordering this way is the same, but there is no index for the first or second or third element and so on. Okay, so that's about the defining, declaring, or accessing different elements. In the next video, we will see more about the data structures. Actually, I want to spend some time on the data structures, because that will be a basic building block for the data science packages. To if we know very well about these data structures, we will be very fluent in the data science packages and working with those. Okay, hope to see you in the next video. Okay, in the last video we defined list, tuple, set, and dictionary, and we actually access different values. In this video, I'm going to actually introduce more indexing, how to access list and tuple in particular, because the both are very easily indexable like strings. And I want to show you that all kind of indexing that you have seen in strings exactly works in list as well as in tuple. So let's go to Jupyter and see what a list is. For example, a list, if you print the list, that's the list. It has these kind of values. If you just see the list, for example, starting from index 1, ending at index 3, that means the same. Pick a slice, for example. So index 1 value is 3, index 2 value is 4.9, and the last element is not included. So if you get that, you get 3 and 4.9. So exactly the same kind of indexing that you have seen in strings, exactly that is working here as well. So for example, if I say list, start from the beginning, go to end, but then I just give -1, it will reverse the whole list. I mean, the whole list will be reversed. I mean, all the things that we saw in string, the indexing stays exactly the same in list as well as in tuple. So tuple, for example, let's access element from let's say from the very beginning till the third element. That's not the third element, till index 3, which is actually the fourth element. So tuple and list, they will be exactly indexed as it is. So all the slicing, all the indexing, all the sub listings, all the subtuples, they can be accessed exactly the same way as you've gone through the string. One difference here that I will explain later on, because list is mutable, it is changeable. I will discuss one thing, that when you slice it, when you get a sublist, then actually it refers to the same memory, and if you change the sublist contents, the actual list got changes. That is true for list in slicing, and that is true for sets and dictionaries in the copying the references and so on. So I will discuss that later on, but rest of the things are roughly the same as they're in string. Indexing Actually, indexing is almost the same everywhere in Python. It has this kind of slicing is almost the same. If you know the index, how to index strings, you know how to index lists. If you know how to index lists, you know how to index tuples and strings and everything. And by the way, if you know how to index string lists, you'll be very fluent in NumPy. That's the very powerful data structure. That's the very powerful kind of array processing package. With some differences that we will see, but even the indexing is same in pandas when you are working with large amount of data files and stuff like so. The indexing is more or less the same that you've seen in strings. We will cover indexing, masking, and fancy kind of indexing in much more detail in NumPy, but this stays the same as you've seen in strings. Okay, so now can we expand the list? Can we add more elements? Can we insert more elements to the list? The answer is yes, because list is changeable, mutable. You can insert more elements. One way of inserting that is just to call an add operator. You just add plus and you just insert another list. So like two strings are concatenated by plus, two lists can be concatenated or combined together again by plus. But there is a faster function called append, l.append, that is sometimes faster than using this operator. We will see that. Tuple, because it is immutable, you cannot touch any content of the tuple. You cannot actually insert any element to a tuple. You cannot delete any element to a tuple. There are workarounds, for example, convert a tuple to a list, change it, then convert the list to a tuple. There are ways to do that. But tuple in its true sense, in the literal sense, it is immutable. You cannot insert any element, you cannot delete any element, you cannot change any element. However, you can combine two tuples together, you can concatenate two tuples together again by plus operator and save the result into a new tuple. That's possible. Set, you can insert elements using an add function. Add function allows you to just insert one element. If you want to insert more than one elements, then you can call an update function that actually accepts more than one element, that accepts another set that need to be inserted. That's possible. Dictionary, you can insert a new key by just d, new key equals to that. You just assign a new value to a new key and the key value pair is just inserted there. Great. You can delete or remove any element from the list using del command, del L1. That means this particular element is deleted from the list. That is possible. Deleting particular element from the tuple is not possible. However, you can delete the whole variable, whole tuple. That is possible. You can remove elements from the set using remove function, s.remove. And then you just give the element that you want to remove. That is possible. It will be removed. And you can delete the whole variable. That is always available. Similarly, you can delete a particular item from the dictionary by just calling the d of the value. For example, whatever the key is. So you call with the key and call delete, and it will delete everything. I want to mention here to remove items from the list, there are other methods and functions that are also available. That there is a remove function, there is a pop function. These are available. Similarly, from removing elements from the dictionary, there are other functions that are available. But just to compare them together, I'm using this del command, although there are other ways of doing the same stuff as well. So let's end this video here, and in the next video I will show you all these operations that concatenating together, inserting more elements, deleting different elements. I will show you all these things in Python. So hope to see you in the next video. Okay, in the last video we saw how to insert different elements to different data structures. And for example, in the case of tuples, it is not possible. And we also saw how to actually delete different elements wherever possible. So let's go to our friend Jupyter Notebook and see all these concepts in a running form. So let's go. Okay, so let's, for example, we have list. That's our list. Let's append an element to the list, or maybe more elements. That is L plus, let's say we can have another list, for example, how, or that's 6, and then U. That's it. And these two lists will be appended, and the new list will be, as you can see, this. Similarly, we can append an item using append function. For example, 6.8. That will also be appended, and the list will contain these kind of values. So yeah, so both ways are fine. This plus is this plus can be used to append to lists, and this append function can be used to simply append a list with an element. Okay, great. Tuples, you cannot change a tuple. You cannot change a tuple, but what you can do is you can have two tuples. For example, T2 is a different tuple. Let's say A and B, and let's say you have 45. Let's say that's tuple 2. Then you can have a third tuple that is just the combination of tuple 1 and tuple 2. And in this case, you have tuple 3, which is this. Yeah, so tuple 1 and tuple 2 are combined together, but you cannot actually insert into the tuple is immutable. You cannot insert another element. You cannot delete the existing element. You cannot update any element, and so on. Similarly, S, the set, let's see the state of the set. That's the set dot add function. You can add anything. Let's say 56, that is added there, and the new state of S is this. Or you can call the update function, if you update method, if you want to insert more elements. For example, if you have multiple elements to be inserted, 23 game, and let's say you wanted to insert an element that is already there, so for example 1, then the duplicates will no longer be there, but the new elements will be inserted. Now let's see the state of D. The state of D is this. If you want to add another key value pair, you can add a key here. For example, a key might be new key, for example, new key, and the value might be for example, the new value. And now if you see D, the contents of the D has changed. Wow, that's simple. Yeah, great. Can you concatenate two dictionaries together using a plus operator? Is it possible? Is it possible to concatenate two dictionaries together? Let's say I have another dictionary T2 that is let's say the key is Y and the value is YY, and then we have another key, let's say Z, and the value is let's say 10. Can I concatenate D and D2 together? Can I just update my D and add these values, insert these values also there? Okay, I left you with this question. You try to answer this, and in the next video I will answer this question, but try to answer this question yourself. And one way to try that is just to go in Jupyter and just type and check whether plus is working or not, or maybe there is another method and stuff like so. Okay, great. Hope to see you. Oh, I have not used the del, delete, and all that stuff and so on. So this question is there. Let me use the removing the elements. So let's say L is this list. If I want to remove any element, let's say element number 3. If I want to remove element at index 3, which is this string name, I can use simply this delete, and the L is everything but without that element. Similarly, I can remove, if I want to remove any element from S, I can call the function remove, and whatever I want to remove, let's say I want to remove game, and the game will no longer be there. Great. If I want to remove some element from dictionary, Again, let's say that's the view of dictionary. I can call D, and I can remove the element with key, let's say C. Whatever the element is with key C, delete that element, and the dictionary has this particular state with this item. This particular item is gone. Okay, great, I can do that. But DEL is not the only way of doing that. There are so many methods, I mean a lot of methods to do that. But just to compare all these, I'm just giving you the most similarities and differences wherever available. Okay, great. So I have asked you a question in this particular video. Can we concatenate two dictionaries together, particularly with a plus operator? If yes, then we are done. If not, then are there other ways and stuff like so? That's a question. So hope to see you in the next video with more on these data structures. Okay, I asked you a question last time. Can we concatenate this two dictionaries together with a plus operator? So what's your answer? Yes or no? The answer is no. Yeah. So we cannot concatenate them together. We cannot insert another dictionary to this dictionary using a plus operator, because this plus operator is not defined for dictionary. What we can do is we can call an update function, because dictionary is also a set. I mean a set of key value pairs, but at the end of the day it's a set with specialized function, of course. But we can call update functions and insert the whole new dictionary inside dictionary as follows. Yeah, so the answer is using plus operator, no, but there is a way using update method. Great. So next we focus on the copy function. The copy function is available for list. The copy function is available for set. The copy function is available for dictionary. So let's see the need of this copy function. Here I want you to be very careful because that's really important. Let's say we have a list. Let's say that's a list. And by the way, the same goes with set and dictionary as well, whatever I'm going to do with list. Let's say you have a list. Now what you do is you copy the list, or you just make another variable, like you can assign the value of L to another variable L2. What you do is that. Now L2 is this. Now these are two different variables. L is this variable, L2 is this variable. So you might be thinking L2 is separately completely a new thing and L is a new thing. You might be thinking that both are independent. But Python internally manages the data structures, most of the data structures, in a way that, because the data structure is a collection of a lot of data, it is consuming a lot of memory. What it does is, when you assign a variable or data structure to another variable, it does not actually copy all the contents. It does not actually make a new memory and store the contents in this. It actually, this variable also actually points to the same memory as this. And the consequence of that, if you change any value, for example in L2, let's say you change the index 2 value from this, the index 2 value is 4.9, now you're working in L2. Let's say you change this L2 value from 4.9 to, let's 4.9. Let's say you do that. So you might be thinking that this happens in L2. Well, in L2 that has happened. But what it also does is it does the same thing in L as well. So L also changes. The reason is L and L2, they both are pointing to this structure in the memory. And whether you approach that structure through L or you approach that structure through L2, you are approaching the same memory anyway. And that is called referencing. I mean, it does not create the data, it actually creates a reference in the memory. It actually creates a new name for the same memory. And both are pointing to or accessing to the same memory. And if you really want the behavior so that L2 becomes different than L, and whatever I do with L2 that should not affect L, then you should call copy function. L2 is L dot copy. Yeah, so that's the function, L dot copy. Now you have L2. Now you do whatever with L2, it will not affect L. So L2, for example, index at index 2, you again say, okay, this is 4.9. So L2 changes now. L2 changes, but L doesn't change. L doesn't change. L stays the same. Now this has different copy. Same concept go with the set, and same concept go with the dictionary. If you just make another variable s2 and equals to s, then if you change the contents of s2, s will change. If you don't want that, then copy it. Similarly, copy the dictionary. Because the contents of the tuple, they are not changeable, the copy function is not available for tuple. Because even if you assign this t to t2, you can now not change t2 because it is immutable. So having a copy function doesn't make sense in tuple. Great. One more thing regarding slicing. Let's say you have L that's available to you like so. That's L, and let's say you make L3 another list by slicing. Let's say a list from 1 to 5. Let's say. So you start from index 1, which is 3, and you go to 5 by not including 5. This way, the L3 is automatically a copy. It is not a sublist which is referencing. So L3 is a different. L3 is a completely new list, a new memory view. If you change the contents in L3, for example, L3 at index 0, it should go from 3 to, let's say, 3. If you change the contents in L3, these change will not reflect in L. So if you do the slicing, slicing picks a copy by default. It does not picks a reference. And that's a huge difference between this list and a NumPy array. And we will see that when we will see a NumPy array, the slicing actually also again refers to the same memory location, and that might be one difference in indexing. Indexing in the whole Python, whenever you do slicing, you get a copy. But in NumPy, when we will see NumPy in detail, in NumPy when you do slicing, you get again a view, not a copy. And if you change in the sliced variant anything, the actual contents also change. And there is a reason to do that, and there are efficiency reasons to do that and stuff like so. Again, the copy function becomes much more applicable there as well. So you need to know that even if you do slicing in general in Python, in any collection, in any array, in any if you do collection for mutable objects like list, you get a copy. But in NumPy array, this particular thing, with a lot of other things, this indexing scheme actually changes with this kind of slicing. Okay, so I end this video here. I mean, you can explore much more functions of list, tuple, set, and dictionary, and what you can do with each of them, and in which scenario, what kind of thing is more suitable for the other. That completely depends upon the problem at hand. But what we can do what we'll be doing in the next video, we will be seeing some functions of just list, and then I will be just letting you to explore the tuple, set, and dictionary and all their functions on your own, and to see what function or what method is doing what for which kind of data structure. So in the next video, we will be seeing some methods just for list data structure. Hope to see you in the next video. Like in strings, let's explore a lot of functions in list, although in sets and dictionaries and tuples as well, but many more functions are available in list. And by the way, let's see how many things are there in this list. Let's say l.tab, and tab will open up a lot of things for me. Append we know already, clear, copy we know already, count we don't know, count, extend, index, insert, pop, remove, reverse. Some of these functions they make sense by just their name, but let's see one by one. Let's see some of those, what they do. One way to do that is go to internet and see some book or tutorial or something like so. Another way is just write this, apply maybe help function, maybe apply a help function. It may help you how to use that. Great, this help function is great. So append an object method of built-in list instance, append object to end of the list. Oh, it appends an object to the end of the list, which means we may be able to append another list to a list. Maybe. Have we thought about that? The append method just takes one object. Maybe it takes a whole lot of list. But then it may be possible that a list is appended inside another list, and that whole list becomes one element, because list can contain other lists as elements. Well, that's a problem. Yeah. So let's see more functions. Yeah. So let's see clear. Well, what this clear? What is this clear? What it does? Sometimes I use help, sometimes I use that. Remove all items from the list. Oh my God! If you call the clear, the list is empty. Okay. If you just call clear function on a list will become empty. Be careful. Okay, great. What else? So let's see. I have this function, maybe pop. What it does? Pop does what? So let's see. So pop removes and returns item at index, default is the last, which means if you also, that's a default value. Remember the default value? So if you call a pop function without an index, it will remove the index, it will delete the last item, and it will give you that, it will return that. Or if you give an index, it will remove that value at that index, and it will, after removing, it will return you that, so you can use it wherever you want. So there are many more functions. For example, you can see all of them one by one. Remove function, for example, reverse like the name suggests. If you call the reverse function, the list will be reversed. Yeah, and remember, we have reversed the list in the following way as well. We have a way of reversing any array this way. So now if you see, the list is again reversed. So I guess both of them are working like so, same. Similarly, you can explore several functions from a set. You go and say add, clear. Clear might be working as same as intersection and update, is disjoint, is a subset of the other. Yeah, add by default or update by default actually take a union. So I'm not seeing update function here. Where is update? Oh, union is there, update is there, which means the list you are seeing is here is not a complete list. You may be writing what are the functions that start from U, so here are they, and several others. Similarly, you can go to dictionary and call for several functions: clear, copy, from keys, get, items. Oh, that item might be interesting. What is this item? What it does? Oh, it has an error. What? So how can I use this? How can I use this function? Let's see. Oh, this is just an object. It is not a function. I don't know. Let's see again. Or it is not listed anywhere. Oh, it is items, not item. Okay, items. That's a function, maybe. So these are all the items. 23 with this, B with that, new key with that, and so on. Great. Actually, the purpose here is not to tell you each and every function and what it does. It will take a whole lot of time. You can go and explore all these functions. The purpose here is to tell you what kind of data structure has what kind of properties and what are the similarities and differences in between. So if you remember this one slide for list, tuple, set, and dictionary, and some text that is written out above, you'll be having very good knowledge of where to pick what kind of data structure in practice. So in the next video, I'll be actually going to Jupyter Notebook as our style, and I will be coding or solving some problem for you that will involve list, tuple, set, or dictionary, or one of them, or we will be choosing based on problem what kind of data structure is well and what. So we'll be doing that. But before that, I just want to mention that list, tuple, set, or dictionary, they can contain any items inside any kind of type, which means a list can contain another list. A list can contain a set, a list can contain a dictionary. A dictionary can contain a list which itself contains a dictionary. I mean, this is all abstract. This is all abstract. One thing can contain the other. One thing can contain an instance of, a list can contain multiple lists, and those lists can contain more lists and so on. Before actually going to problem solving, let me give you a flavor of that, how abstract these things are. Let me give you a flavor of that in just in a couple of examples. So in the next video, I'll be giving you a couple of examples based on the abstractness of these data structures, and from the next video we will be doing some problem solving based on that. So next two videos are completely on Jupyter Notebooks, so get ready. Hope to see you in the next video. Okay, let's see the abstractness of all these data structures. Let's see just one example. Let's say we have L, that's the list. We have already tuple, that's tuple. Let's say we have set, that's set. Let's say, and we have dictionary, that's a dictionary. Okay, so let's say we have all these things, let's say, available somewhere. So let's make another dictionary. For example, let's say let's say D2, and that dictionary has key value pairs. Let's say the key is A, and the value is the whole list L. That's the value. This is possible. Let's say the key is B, and the value is just a tuple, the whole tuple. That's the value. Let's say the key is C, and the value is the set. And let's say the key is D, and the value is the dictionary, the whole dictionary D. It is possible. I mean, you can just do that. That is just one example. Oh, sorry. I should have incorporated this way. Okay, so this is possible. Now, for example, if I access the element with let's say A, I will get the whole list. And not only that, I can access the whole element, and then after that, for that element, I can access, for example, the third element, the element at index 3. So this particular first level will extract the list, and that is just the indexing or for that list. See, for example, if I access D2, and inside D2, if I access the dictionary that is inside, and let's say I save that dictionary in K, then I can see the contents of K, but I can just, for example, this, or I can just access all the elements of this dictionary or K by just having for X in K, print, for example, X and K of X. Just do that. I can just do that. We have done that in loops as well. So I want to tell you that these even if, for example, if you want to create a list L, let's say L3, let's say you want to create a list that can contain the whole list, that can contain one element is the list, another element is a tuple, another element is the whole dictionary inside, and then you have some other elements, let's say these game, and that's perfectly fine. You can do that. These data structures are much more abstract. Now if you, for example, access element at index 2, which is dictionary. That is completely a dictionary. If you check the type of that element, that will be a dictionary object, and you can extract that element and play the way you want to play and whatever. One more thing, we can, for example, lists, we can let's say we want to make a list very quickly. For example, list of all the squares till starting from 0, list of all the squares till 10. For example, 0 square, 1 square, 2 square. Let's say we want a list of that. So one way of doing that is, a quick shortcut is to just use the loops. So in loops, for example, we write, okay, x square for x in range 10, for example. So it will start from 0, go till 9, including 9, and you will get x one by one, and all this syntax is for making a list of x squares where x starts from 0 and go till including 9, go till 9 one by one, and that's how you can make a list. And I mean, these are kind of shortcuts. Again, you can make a set. For example, let's say you want to make a set of all the squares for x in range, let's say starting from 2 ending at 20, and you want to take a step of, let's say, 3. So start from index 2, go till 20, do not include 20, but take the step of 3, and you can now have a set which is this. I mean, there are a lot of ways of working with these. One can explore more and more about these things, but what the basic thing about these data structures are, they are very, very abstract. They can, I mean, a list can contain a dictionary, and that dictionary can contain a tuple, and that tuple have an element which is another list, and so on. It is that abstract. It allows you to do each and everything in that way. Okay, so I end this video here. In the next video, we will actually solve a problem using these one of these data structures, or we will try to choose one of those. And that video may be lengthy, may be small, because we may have bugs inside, and we will play around with these data structures in the next video. So do attend the next video, because it's really the practice, and you will get your hands. You will get a very good grip on the data structures in solving the next problem that we are launching for you. Okay, hope to see you in the next video. Okay, let's see a problem just to get comfortable with these data structures. So let's design some problem and solve that problem here using these data structures. So the problem that I'm thinking is, let's say, the following. Let's say you are a teacher. Should I type all these things? Okay, yeah. Let's say you are a teacher. You are a teacher, and you have different student records containing ID of a student and the marks list in each subject, where different students have taken different number of subjects, and all these records are in hard copy. You want to enter all the data in computer and want to compute the average marks of each student and display. That's the problem. So the problem, let's say, is you have, for example, you have a hard copy, you have some papers upon which you have different students. Each student have a different ID. Some students may have taken 7 subjects, some student may have taken 3 subjects, some student may have taken 8 subjects, and so on. Different students may have taken different subjects. Records is there. You want to first enter, for each student, you want to first enter the records, I mean all the data that is in, and then you want to compute from that data, you want to compute the average marks of each student. For example, if a student have taken 5 subjects, then the marks for all the 5 subjects are available. You just add all the marks and divide by 5, and that's, let's say, the average marks. So first of all, let's write a way to compute, for example, the to just collect the data. How to collect the data? So let's write a function for that. So let's say define a function. Let's say get data from user or teacher. Let's say, and let's say that's a function, and it returns data. Okay, so what I do really is I say, okay, while true, I made a loop while true, just take the data from the user, and the data is in the form of you first say, okay, ID, student ID, let's say that is enter, or actually input, enter student ID. So he enters the person enters the student ID. Yeah, so on top you might have defined a dictionary, maybe a dictionary D that is empty right now, but you may add and remove different values. So what you do is you add a student ID, you get a student ID, and in the string form, and then you get the for example the input as the marks list. So marks list as input, enter the marks by comma separated values. So enter the marks using, for example, if you have 5 subjects, just write the 5 subject marks by separating each with the comma. Okay, then let's say more students is equal to, let's say, input enter yes or no for adding more students. So if, for example, you have more data to insert, then press yes, otherwise press no. So that's, for example, our setup. So we will keep on getting more and more, we will keep on getting more and more data from the user. User will keep on entering the data. But one thing that we must know is that if, for example, a student ID is already in D, if that is already in D, then we should give a message print print that student ID is already inserted. So that might be a message. Else we want to do something. Else what we want to do is the following. What we want to do else is we will make a dictionary. We already have a dictionary. with the student ID as our key. That's our key, and at that key what we do is we pick the marks list and just split it using comma, because we are expecting, and all the marks, they will be saved as a list. So that will return a list of string values. These are not integer values, these are string values, but all these lists, they are tagged by this ID. So that is a dictionary that will be getting populated on and on and on. Further, if we check if for example, more students dot lower, for example, let's call the lower function because the user may enters it in a lower form, or if that is equal to, let's say, no, if that is equal to no, if this is the case, or if that is no, enter, for example, no, enter no, enter no to quit, insertion, enter no to quit insertion. So let's say that's your message. So wherever the user inserted, if that's a no, then you return D, and that's it. Otherwise you keep on moving. So that's the whole code. So you keep on asking you keep on asking more and more values. If whenever the teacher enters a no, then you just return. Otherwise you make another iteration, and keep on moving. That's how you get the data. So the data will be available to you once you are done with that. Then after that, we will see how to, once we have this data collected from the user, then we will see how to compute marks for each student individually, average marks, and so on. So let's just check whether this function works or not. So let's say we have our dictionary. Let's say student data is equal to get data from user, and let's just call that function, and let's see what happens. Okay, enter student ID. Let's say ID is 12. Okay, enter marks by comma separated values. Let's say 12, 1, let's say 24, comma 65, comma 87. Let's say the first student just have these 3 subjects. Then enter no to quit, so I will enter something else. And oh, what's the problem? There is a problem. If more students dot lower is, more student is not defined. More student, that's, I guess, more students, more student here. Oh, the spelling mistakes, that's a huge mistake. So I just copy there, these bugs are there, that's part of life, part of programming life actually. So I guess now it will work. So let's do the process again. So 12, let's say, and the marks are 56, comma 45, comma let's say a bad subject with, let's say, 13. Enter no to quit. No, I will enter something else, and I will keep on moving. The other student is the student ID is 45, let's say, and the marks that this student has gained, actually, let's say this student has already registered 7 subjects, or let's say 5 subjects, and the marks are, let's say, 44, 55, 66, 77, and let's say a bad subject, let's say 4. Okay, then enter no to quit. No, I want to insert one more, so do anything else other than no. So student ID, let's say now the student ID is 12 again. Let's say I want to insert another ID again. and whatever the marks, let's say 45 and 45 again, let's say. Now enter node quit, know something else. But now the message is there. The 12 is already inserted because the ID, the key value in dictionary cannot repeat, and so is the student value. So it does not inserted because this may be by mistake. So it asks again. So now let's say I enter ID, let's say 23, that's the ID, or maybe a different ID. That's the ID, and the marks are, let's say 45 comma 45, let's say, and enter no to quit. So let's say I enter no, and that's it. So now I have received the student data. If I show you the student data, that student data is student data. That's a dictionary. That's a dictionary with key 12, and that's a list. But this list contains all the values that are string type. We will see how to handle that. That's a 45 as a key value. That's ID, and that's the marks list, and that's the ID, and that's the marks list. Okay, great. Now we have student data. Let's write another function that helps us working on the student data. Basically, we want to find out the average marks of each student, and then we want to print those. So let's define another function, get average marks of each student, and that function actually receives this dictionary. Let me call it as D, any variable, that's a local variable. Okay, so what we want to do with that is the following. Average marks for each student. So we will define another dictionary. Let's say average marks dictionary. Let's say that is empty in the beginning, maybe. And then what we do for X in D, let's iterate over X and D. What we really do is we go to, we find out the list of located at L, located at X. So L is basically D sub X. So let's say that's our list. That's our list that is located there. So then what we do for I in L, so for all I that is in L, or let me call it for marks in L, in this particular list, what you do is you actually have this sum. Sum is equal to 0. Right now there is no marks, so what you do is S plus equals to marks, but convert the marks to integer because they are already in string format. We have saved everything in string format. So you populate all the list. Once you're done with this loop, the S will contain the sum of all the marks. Then what you do is you compute the average and just save that average in AVG marks dictionary, let's say, or average marks. Just don't use the word dict, for example. You can, but let's stay casual. And at X, you just write the average marks, and the average marks can be computed by S divided by length of the list, whatever the list is. So that's what the list is. Yeah, so that's the average marks. And once you have, and one by one, all the average marks will be populated. And once we receive all these, we will then, we can then just display by populating the average marks. So let's see, let's call that function. So let's call that function. So AVG marks, for example, equals to get AVG marks, and let's put the student data inside, and if there is no error, then it will return everything. Then just print the average marks for each student for X in AVGM, print, let's say student, and then print X got average marks as, then you just print okay, avgm of x, x, and that will display everything. Oh, if there is an error, none type object is not iterable. None type object, why none type object? We have done some mistake, yes, maybe. Let's see, for example, when we have run this, so let's run this and create a cell. Let's run using Alt Enter. It will create a cell, average m. What is that thing? Oh, that is nothing. Why? Oh, we haven't returned anything. That's a bad programming, really bad programming. We have not returned actually the value that we need. So the default value is none. Great. Actually not so great. Okay, great. Yes, this. And now we have something in average marks. Yes, this is. And now we can just populate that, and we have the student 12 got average marks 38. Student 45 got average marks 49.2, and student 23 got average marks as 45.0. Okay, great. So that was just a review of split function of string, type conversion through int, and functions in general, input function, and dictionary and list and all that stuff. So although it was just a tiny problem, but it gives a good flavor of the data structures and strings and all that stuff. Okay, that's about the data structures. From the next video, we are actually diving into the data science packages, and we will start from NumPy, and we will spend some time on NumPy, and then we will be moving towards pandas, which is very, very powerful, built on top of NumPy. And after that, we'll be moving towards matplotlib. And we will also try to give you some snapshots of scikit-learn as well. So hope to see you in the next video.